is Unit 2, Segment Lines and Angles, Lesson 2.6, Parallel Lines and Angles. Should be right here in your video notes. Make sure you get your date, time, and location and a parent sign off. Let's do a quick review. In the diagram to the right, I want an equation of a line in slope-intercept form. That's y equals mx plus b. Do the best you can. Pause, turn it back on when you've done your best try. Okay, so if you don't know what to do, you always do what you can do. We know it's in slope-intercept form, so I can at least write the equation y equals mx plus b. Now there's only two things we need here to really figure this out. We need the slope and we need the y-intercept. So for the slope, we're going to count the rise over the run. So you can bunny hop here. 1, 2, 3, 4, 5, 6 over my run, 1, 2, that's going to be 6 over 2, so that reduces to 3 over 1. So I know my slope is 3 over 1. That's my slope. So at my m equals 3 over 1. Problem is, I still don't know where the line crosses the y-axis, and you can see here it flies off the edge. So we're going to have to do this algebraically and ask ourselves, what else do we know? Well, we know the slope is 3 over 1. That we have. The b, we don't know. Let's look at what we have. We do have 2 points here. So we're going to choose either point, and I'm going to choose this point here. That's -1, -3. That's my x, that's my y. So now let's plug it in. Bring down your x, that's -1. Bring down your y, that's -3. And we're going to solve for b here. -1 times 3 makes it -3. So I have -3 Okay, double check a key component here. When we did the slope, we forgot it was negative, or at least I did. You probably didn't, so we have to make sure we get that negative in there. Negative. So now we have -3 equals, that's going to be +3 plus b. Now we solve. I'm going to -3 both sides. I end up with -6 equals b. Here's my equation, y equals mx plus b. So now I know my b, so I can write my equation, y equals -3 over 1 x minus 6. Ask yourself if that actually looks like it's the case. If we were to take this line down, if that's 5, it would cross at -6. So this would be your equation of the line. We're going to continue talking about lines today, but specifically parallel lines. Parallel lines. Lots of vocabulary today. You need to be familiar by the end of this lesson with these words. Skew, parallel, transversal, alternate in, alternate x, corresponding, consecutive in, vertical, linear pair. You should have a coffee stir stick handy. I provided one in class for you. Parallel lines. Most every single structure you are ever going to look at has parallel lines in it, most likely. So, for example, we have parallel lines here, and we have parallel lines going on here. Now, you need to know the difference between parallel and skew. When you were a kid, you learned that parallel lines never intersect. That's true. But there's another type of lines that also never intersect, so watch out for those. I'm going to demonstrate the difference between them right now. Parallel lines never intersect, but they go the same direction. So on this box here, you would trace and stretch these lines out. They're on the same side of the box, going the same direction. We would call those parallel. And you put these little arrow feathers on them. That's parallel. Same direction, never intersect. It's on the same plane, same side of the box. Not to be confused with skew. Skew would be two lines that never intersect, but they're on different planes. So let me highlight a couple of them for you. So here's a line here. And a line here. They're on two different planes. They're never going to intersect. Now it looks a little difficult to see that in 2 dimensions, so I'm going to show you in 3. So here would be your skew lines that we just did. And if you want to see them in 3D, they're going to look like this. Here's my box. Let me turn it so you can kind of see it. So skew lines would be like this. You have a line going straight up and down, like so. And then on the other side, you'd have a line going back here in 3D. They're never going to intersect, but they're in 2 different directions. In other words, one goes this way and one's going to come out this way. Notice they're not touching, they don't intersect, but they're going 2 different directions. That's called skew. I need to introduce some vocabulary to you. When you have 2 lines and it's crossed by a 3rd line, that's called a transversal. So this would be a transversal. Whenever we use a transversal, we're going to get a stir stick. So right here, when you see a transversal, I want you to get in the habit of taking your stir stick and putting your stir stick right on it. That's going to be your transversal. So when I say stir stick and transversal, I'm going to use that interchangeably. Now angles have a certain position around it. A certain position around that. When we have a set of angles on opposite sides of the stir stick, but still between the lines, When I mean between, I mean in between the lines. This is called between the lines. That is going to be, I'm going to do this in blue. That would be an example of angle 4 and 5. Those are called alternate interior angles. Alternate interior. So right here, angle 4 and 5 would be considered alternate interior angles. They're on either side of the stir stick, but they're still between the lines. This would be considered between the lines. That's why they're called alternate interior. Then you're going to have what's called alternate exterior angles. Alternate exterior. There's trace one set of angles which are on opposite sides of the stir stick but outside the lines. An example of this would be angles opposite of each other. 2 and 7 are opposite of each other on either side of the stir stick, but they're outside the lines. I'm doing this in green. This is called alternate exterior. So opposite sides of the stir stick, but outside the lines. That's alternate exterior. We're going to trace one set of angles that are on the same side of the stir stick, but one angle in and one angle out. Same side of the stir stick, one angle in, one angle out. These are called corresponding. One angle in, one angle out. So an example of this would be angle 4 would be the in angle, and angle 8 would be the out angle, and they're on the same side of the stir stick. One angle in, one angle out. This is called corresponding. One angle in, one angle out. Same side of the stir stick. That's called corresponding. The last one is we're going to trace a set of angles which are on the same side of the stir stick, but still between the lines. Same side of the stir stick, but still between the lines. And this, between the lines, same side of the stir stick, those are called same side interior, also known as consecutive interior. So right here, that would be like example angle 3 and 5. Same side of the stir stick, but still between the lines. Alt in, Alt X, corresponding, consecutive interior. We're going to do one together here. So it says lay your stir stick on the dotted line and determine if the pair that's given is going to be alt in, Opposite sides of the transversal but between the lines, Alt X. Alternate exterior corresponding, consecutive interior or vertical angles or linear pairs. So it could be any one of those 6, and we're going to put our stir stick right there and determine what kind of angles those are. So if we put our stir stick down there, the between the lines rotates. So here's your stir stick, and between the lines is going to go this way. That's now considered between, because that's the 2 lines that are being cut across. So there's our stir stick, and it's cutting across these 2 lines. So that means this is now considered the interior. Let's do our angles. First, we have angle 12 and 13. 12 and 13. Sweep it. 12 and 13. Twelve and 13 are on the same side of the stir stick between the lines, so we would call that consecutive interior. Again, 12 and 13 are between the lines and on the same side, so that would be considered consecutive interior. They're between the lines on the same side. Let's do 10 and 15. 10 and 15. Same side of the stir stick, 1 in, 1 out. That's called corresponding. One in, 1 out, same side. That's called corresponding. So we would say that angles 15 and 10, 1's in, 1's out, same side, those are called corresponding. The purple ones were consecutive interior. Angle 10 and angle 15 were corresponding, and angle 12 and angle 13 were consecutive interior. Let's keep going. We want 12 and 10. 12 and 10. Here's 12. Here's 10. They're a bow tie angle, so those are vertical. They're vertical. 12 and 10. They're bow tie angles. They look like a bow tie. They're going to be automatically congruent. So angle 12 and angle 10, they're vertical. Last one is 9 and 16. So let's sweep 9 and let's sweep 16. There's 9, there's 16. Notice we're on the outside, but we're on opposite sides of the stir stick. So 9 and 16, that's going to be alternate exterior. 9 and 16. Come back here, 9 and 16, they're both outside of the lines, but on opposite sides of the stir stick. So we would say angle 9 and angle 16 are alternate exterior. So I want you to do this page on your own. Sweep the angles and determine what they are. Should only take you a few minutes. Pause. Do. Start. All right, take a look. Your stir stick was now over here. It rotated, so when it rotates, things change. See that right there? So we had angles 12 and 13, 12 and 3, 12 and 3. 12 and 3 are on either side of the stir stick, but between the lines. Our between the lines are now this way, because that's the lines being cut across. So that would be alternate interior. So 12 and 3, like this, are considered angle 12, and angle 3 are alternate interior. Angle 1 and 11, they're outside of the lines, but they're still on opposite sides, so that would be considered alternate exterior. Again, 1 and 11. Would be alternate exterior. They're outside of the lines, but on either side of the stir stick. Inside would be between the lines that are crossed by the transversal, so this would be considered inside. So 1 and 11 are outside. That's why we say it's exterior. 9 and 3. 9 and 3, one's in, and the other one's in. So that's called consecutive interior. So 9 and 3, here's 9, here's 3, they're on the same side. We would call that consecutive interior. Consecutive meaning right next to each other, interior meaning between the lines. Last one, 3 and 10. For 3 and 10, we have 1 in, 1 out, same side. 10's out. 3 is in, same side. That's called corresponding. So taking a look here, 3 is in, 10 is out, 1's in, 1's out, corresponding. All right, now when lines become parallel, all these angles have a certain relationship. When lines become parallel, all these angles have a certain relationship. When lines become parallel, all these have a certain kind of a relationship. So parallel, when things are parallel, we put these little arrow feathers on there. And when these angles become parallel, the alternate interior angles become congruent. So that would be, again, between the lines, but still inside. So that would be like angles 4 and 5. Those are going to be congruent. Let's just write these in and then I'll give you the demo. When lines become parallel, just write this down. Alternate interior angles become congruent. When lines are parallel, alternate exterior angles are congruent. When lines are parallel, corresponding angles are congruent. Keep in mind, when you see vertical angles, they are always going to be congruent. Vertical angles are always going to be congruent. So let me give you an example of each of these before we go on. So in this case, we have alternate interior angles. That would be angles 4 and 5. When lines are parallel, these guys are going to be congruent. But 3 and 6 are also equal. Those are alternate interior angles. A set of alternate exterior, alternate meaning opposite sides of the stir stick. So there's interior between the lines, there's your stir stick. So alternate exterior would be something like angles 2 and 7. Those are going to be as congruent as well. Alternate exterior are congruent. Corresponding, one's in, one's out, same side. There's 4 sets here. I'm only going to do 1. So one's in, one's out, same side. So that would be something like angle 5 and 1. This one's in, this is out, same side. These guys are going to be congruent. Then you need to watch out for vertical angles. Vertical angles are always congruent. So a vertical angle, an example of that would be like 5 and 8. Those are vertical. So when lines become parallel, all of these angles are equal. Verticals are always congruent. And when lines become parallel, the consecutive interior angles are going to be supplementary. Consecutive interior angles are going to be supplementary. Linear pairs are always going to be supplementary. Those are the ones that share a spine, make a line. So if you go back here, all of these were congruent. The 2 angles on the same side, like 4 and 6, those aren't congruent, but they do add up to 180. So 4 and 6 are going to add up to 180. Another set of angles that would add up to 180 would be any 2 angles that share a spine, make a line. So that would be an example like 1 and 3. Add up to 180. One of the most critical angles you need to be able to spot are the alternate interior angles. Let me show you what those look like. Let's say we have two lines. Take this C, draw two lines, and then we have a transversal. I'm going to make it red like a stir stick. I call these angles alternate interior angles. So that would be like this one and this one right here. I have a name for those. It's slang, obviously, but it comes in real handy. These are called armpits of the Z. So think armpits of the Z. Those are called alternate interior angles, by far the most important ones. Armpits of the Z. Could also be rotated. You had lines going this way, and when lines are parallel, those are equal. So if I had parallel lines going like this, and I have a transversal, these would be the armpits of the Z. Armpits of the Z. Let's see if you can't look in this diagram. I'd like you to find at least 3 sets of armpits of the Z and trace it. 3 sets. See if you can't find them. Ready? Here's one. Armpits of the Z. Right there and there. Let me change colors here. There we are. Nope. So armpits of the Z, there would be one. Here would be another. It'd actually go the other way. Here would be another over here, kind of a squat Z. Those are all congruent. Those are called armpits of the Z, also known as alternate interior angles. So what we're going to do is we're going to come over here, we're going to sweep A and B and determine what relationship they have and the position. For example, let's sweep A and B. Their position, they are alternate exterior angles. And when lines are parallel, the relationship is they are congruent. Here, A and B here, their position, one's in, one's out, same side. Those are called corresponding. Their relationship, when lines are parallel, they are congruent. A and B, if this is your stir stick here, A and B, those are called consecutive interior. And when lines are parallel, they are congruent. I'm going to do these guys with you. I think you need some more practice. So let's keep going here. I'm going to draw on my red stir stick each time. So here's my stir stick. Let's trace A and B again. That's between the lines, opposite sides of the stir stick. That's going to be alternate interior. And when lines are parallel, they'll be congruent. Here's A and B here. This is from a while ago. They share a spine, they make a line. These guys are a linear pair. they are not congruent, but they do sum 180. For this one, here's your stir stick. Let's trace A and B. Trace that with me. Notice we have armpits of the Z. That's going to be alternate interior. So we write alternate interior, and when lines are parallel, they are congruent. Here's your parallel lines. There's your transversal. Sweep A, sweep B. Opposite sides of the stir stick, that's going to be alternate exterior angles. And when lines are parallel, they are congruent. Sweep A and B. Here we have one in, one out, same side. When lines are parallel, those are called corresponding. They are congruent. In this case, A and B, they're vertical. And they are always congruent. So taking a look at this page, our goal is to find everything possible knowing those lines are parallel. Let me get my page here. We're going to do this one together. And we'll do the next one together for time's sake. Taking a look. Okay, we notice here that the lines are parallel, and our goal is to find as much as we can. So I'm going to lay my stir stick down over here, and we're going to find as many things as we can. So the first thing I'm going to find, which is the easiest to find, are what are called armpits of the Z, and I'm going to trace it with my highlighter here. We have a Z here. Do you see it? Armpits of the Z. So that means that's alternate interior angles. If this is 105, that means this is 105. Because they're alternate interior angles. Vertical angles, that means these guys are right across from each other. That's going to be 105 as well. This 105, one's in. It's the same as that right there. Because it's corresponding, it's also vertical. This is going to be 105. Then I have here another armpits of the Z. Armpits of the Z. Careful here. Watch very carefully. There's our stir stick. So this is 105. That means all the way from here to here is 105. That's our armpits of the Z. Now we see here these two angles. This angle and this angle here, they share a spine. They make a line. That means they add up to 180. So we can take 105 away from 180, and this is going to be 75. Vertical, also 75. Armpits of the Z. That means this is 75. Vertical angles, that's 75. We go this way, armpits of the Z, that's 75. Now we have another number there, so we're going to remove our stir stick because we have basically two different stir sticks. Now let's walk this down on either side of the stir stick. This is an out angle, right? Now let's do an interior angle along the stir stick. That right there is interior. One's in, one's out, same side. Those are corresponding. That means that is 59. And if they're parallel, we can walk it down here. This is also corresponding. That's also going to be 59. Vertical angles, that's going to be 59. This is a linear pair again, going this way. See these two angles? They share a spine, make a line, so we can take 59 away from 180. And we're going to get 121. Vertical angles, this is 121. Ready? Armpits of the Z. That's 121. Going this way, armpits of the Z. 59. You see the pattern here? 121. That means from here to here also has to be 121. Vertical angle 75. So you can see the minute you have parallel lines, you got a mess of information. Let's try one more together. We're going to do this again together because I think we need the practice. Okay, keep in mind this, that when lines are parallel, these angles are congruent. Alternate in, alternate x, corresponding and vertical will always be equal when lines are parallel. Supplementary, consecutive interior, and linear pairs. Ready? Let's do this last one together. We have two stir sticks. So I'm going to start with this one stir stick here. So following that stir stick, I'm going to do armpits of the Z. Those are always equal. So armpits of the Z. There's my armpit of the Z. That means if this is 86, this is also 86. This is in, one's out, same side, that's corresponding. That means this is 86. Alternate exterior, either side of the stir stick, outside the lines are also equal. That means this is 86. Let's see what else we can find. We have a linear pair here, which means it adds up to 180. So we can take 180 minus 86. You get 94. That means this angle over here has to be 94. Let's walk it up the stir stick. Vertical angles, that's also 94. Here, armpits of the Z. Trace. See that Z? Careful with this, because we're actually overlapping a bit. That means if this is 94, all of this is 94. Going this way, all of that is 94. Let's move our stir stick and let's work this side. Ready? If this is 100, we have a vertical angle here. That's 100, right across from each other. Now we're going to do alternate exterior. Go across the stir stick to the outside all the way from there to there. That's 100 as well. And if that's 100, let's check our linear pairs. This is a linear pair. Adds up to 180, which means this has to be 80. Vertical angles, that means this is 80. The armpits of the Z. Ready? Armpit of the Z, going this way. You see the Z there? That means this is 80 on this side. And that's 80 right there. Which makes this little guy 80 from 94, that's going to be 14 degrees. That, my friends, is Squeeze the Sponge.